Today I'm going to show you how this AI-based irrigation scheduler works. So the first thing you can do on this irrigation scheduler is you can choose a location for your irrigation sites. For instance, if your irrigation site is in Maryland, you can choose Maryland, or you can also manually edit this the latitude and longitude of your irrigation site. Once you have these two coordinate points, you can save the location, and then you can also choose whatever crop you have in your field. If you have maize, you can choose maize, or if you have tomato, you can choose tomato. But if you don't see your crop here under this list, you can go to manage crop and then put the name of the crop, and then you can also choose the category of the crop, and then you can also add whatever description you want to add. In addition to that, you can also edit the crop coefficient of your crop. For instance, if you know the initial stage, developmental stage, mid stage, and late stage crop coefficient of your crop, you can edit this, and then you can also edit the rooting depths and depletion factor, whatever depletion factor you are considering. If you don't know what is your depletion factor for your crop, you can just use 50%, which is commonly used factor for most crops. You can also put the water requirement, and then once you have all this information, you can save your crop, and then for next time you don't need to do the same thing. You can come here and choose whatever crop you have. So once you do that, you can here you can see what are your crop coefficients during the different growth stage. So for the soil information, here we have two options. One is the manual option, and the other is the API option. For the manual option, what you can do is, if you have the field capacity and then permanent wilting point of your soil, you can edit this number, and then you can also, if you have current soil moisture content of your field, you can choose whatever percentage you have here, and then you can also edit the rooting depths. And then once you do that, what you can do, you can go here and calculate your irrigation. First, you can check whatever your water balance summary is. For instance, here we have total available water, which is 100 millimeter, and then readily available water is 55 millimeter, and available water is 30 millimeter. And then from this information, from whatever field capacity, permanent wilting point, and current soil moisture content, you can calculate if you needed irrigation or not. For instance, if I click here, it says you need irrigation. From the as you see here, the amount of water we have now is not enough to fulfill the crop water requirement. So because of that, we need irrigation. But here, if you have rainfall, so if the rainfall satisfies your crop water requirement, you don't need to irrigate. But as you see here, our app also includes weather parameters. It extracts weather parameters from API. So from that, we can see how much effective rainfall we have. For instance, in our case now we have 0.3 millimeter of rainfall, which doesn't satisfy our crop water requirement. So because of that, we need irrigation. We should apply 69 millimeter of water over 8.6 hours. So this is the first option for your soil information. If you don't have this information, the field capacity, what permanent wilting point, and then your current soil moisture content, what you can do is you can extract the soil moisture content from API. So you can fetch the information from API. As you see here, when I click fetch, so I have 28% of soil moisture content in my soil. So let's calculate our irrigation again. So here, from what we collected from the API, it says we don't need irrigation because the current soil water is around 180 millimeter, which is above the readily available water limit. So these are the main component of the app. So here you can also choose your soil type. For instance, if you have sand, you can choose sand. If you have clay, you can choose clay. So depending on the type of soil you have, your field capacity and permanent wilting point is going to change. So once you decide whether you need irrigation or not, what you can do is you can come here, the scheduler, and then you can schedule irrigation. You can come here and put the title of the irrigation, which part of your field are you going to irrigate, and what is the crop you have in your field. You can also put time and date, and then if you needed to repeat this irrigation by weekly or monthly or whatever, and you can also put the amount of water you needed to apply, the duration, and then how this irrigation schedule is prioritized. The priority is low, medium, or high. Depending on the priority, you can choose a different priority. And then we can also have a weather data which we fetched from API. So here, once we fetch the weather data from API, here we use different techniques to calculate a reference evapotranspiration. The first method is we are using Penman, Montes, or FAO56 method to calculate the reference evapotranspiration. We have also option to calculate reference evapotranspiration using machine learning models. So we have random forest, neural network, extreme gradient boosting model, and we have also a simple model which combines the prediction of these three models. And then we can also compare the ET estimation, the reference evapotranspiration estimation, from different methods. These are the first three ones are the machine learning methods, and the last one is the FAO56 method. So as you see here, there is a big difference between the FAO56 and the other three machine learning models. So here you can also see how the soil moisture content is varying for 2 weeks. For instance, here we have 14-day soil moisture content dynamics, which we fetched it from the API. Here you can also see the 7-day weather forecast. So depending on this weather forecast, you can schedule your irrigation for coming week. So we have also an option to add a special map for scheduling irrigation for a big area rather than relying on a point data. What we do is we extract our whole field and then schedule the irrigation based on the special map. We are also going to have vegetation indices such as NDVI and EVI, so farmer can see how their crop or how the different part of their field is performing based on this vegetation indices. And we are also going to have crop information. For instance, if a grower or a farmer have a different crop in their field, they can check their crop on this page of the app. So the last part of the app is the API. These are the APIs we are using for extracting weather data, soil moisture content, and then soil moisture content and weather data. So all these three APIs are working fine for now. So this is how our AI-based irrigation scheduler is works. Thank you for listening. Let me know if you have any question or suggestion. Thank you.